Hi everyone. I said in my last video that we'll talk a little bit about the 14-3-3 proteins. It's just in my notes, it's a little ambiguous to me right now, and it's like I said in my previous video as well. It's sort of like a topic that has branched off. Like it's related to cell signaling, obviously, but it's not very. It's I don't find it as clear as of now, and there's bits and pieces here and there, and to start that topic from scratch is would be a little ambiguous at this point, so I'm gonna leave that for a later time. So for now, we go back to our general signaling concepts, and now we'll look at a little bit into detail about receptors and the messenger molecules. Okay. Okay, so a large variety of molecules can function as extracellular I can't speak anymore. Extracellular carriers of information, including. So first we're talking about messengers. Then what things can act as messengers for these signaling pathways? So you can have amino acids or amino acid derivatives. Okay, so you can have things like glutamate, glycine, acetylcholine is a classic example. You can have epinephrine, dopamine, thyroid hormone, so these are the classical ones. And then you can also have steroids working as messenger molecules, and these steroids, as we all know, are derived from cholesterol molecules. And then we can also have things like eicosanoids, ico or eicosanoids. Okay, so you can have all these different things acting as your messenger molecules. Extracellular signaling molecules are usually, but not always, recognized by specific receptors that are present on the surface of the responding cell. And we've already talked about this in a lot of detail in previous lectures. So you have your plasma membrane. On your plasma membrane you have these receptors, and these receptors can take up messengers or ligands, and that will cause the signaling, the downstream molecules, the downstream pathways to be activated or inactivated depending on the kind of signal that has been sent. This is like the basic setup. So you almost every time you have a receptor that will take up that ligand. Receptors bind their signaling molecules with high affinity. So obviously, if the signal needs to be transmitted efficiently and properly, then this really has to be, this binding here has to be of high affinity. Okay, they then translate this interaction at cell outer surface into changes that take place on inside the cell. So these things are happening on the membrane, and then whatever the response is inside the cell, right? The receptors that have evolved to mediate signal transduction, I'll just brief them here, and then in the next video we'll continue on. So we have the GPCRs, we have receptor tyrosine kinases, we have the ligand-gated channels, and we have steroid hormone receptors. Steroid hormone receptors. So we'll continue this in the next video. We'll start off with GPCR. We'll give a brief introduction to all of these and then get into the details of GPCR. Alright, see you guys in the next one.